The IDE also comes with a debugger that gives developers powerful tools for examining the internal state of a running application. And this can be useful, of course, when you have a bug in your application and you're not sure exactly what's causing it. So let's use the debugger to examine an application. Here I'm showing you a simple Android application I've named The Answer. And this app is supposed to show you the answer to life, the universe, and everything, which, as the Hitchhiker's Guide to the Galaxy tells us, is 42. And as you can see, however, instead of displaying 42, this app says, "We may never know." So clearly, there's a bug somewhere. Let's use the debugger to track that bug down. Now here we are in the IDE. First, I'll open up the Answer application and show you its source code. Now, the truth is that this is a pretty silly program, and the bug would be fairly obvious once you've looked at the code a bit. But my goal here is to show you how the debugger works, so just between you and us, let's pretend that we don't know what's going on. Now you can see that there is an array called manswers, through which the program will search, looking for the answer 42. Now here's the onCreate method, which is the starting point when this class is executed. Inside onCreate, there's a call to a method called findAnswer, and the code for the findAnswer method is listed down below. Now findAnswer is supposed to search the manswers array and return the number 42 if it's in there, or -1 if it's not. Now going back up, the program stores findAnswer's return value in the variable val, and then uses the variable to compute a string called output. And finally, the program calls the setText method to display the output string on the screen. So let's say that since I don't know where the bug is, I decide to debug this program. The first thing I'll do then is to set a breakpoint that stops the program when it enters the onCreate method. Now, instead of running the program, I'll debug it by selecting Run and then Debug App from the application bar, and I could have also just typed Control-D as well. I'll click OK to run this on my phone. And when the application reaches onCreate, it stops and shows me the debug view with the current line highlighted in the source code. At this point, I'll step through the code line by line, examining the program's state. To step forward, I'll select Step Over from the debugger toolbar, which advances the program one line. Let me do that a few more times. And I'm now at the line that calls findAnswer and stores the return result in the variable val. Let me step over this line. Now once I step over this line, you'll see that the value of the variable val is now -10, which is already a problem. It should have been 42. Now if I advance again, I see that the output string is set to "we may never know." Okay, so the problem is certainly down in the findAnswer method. So let's look more closely at the findAnswer method. To do that, I'll put a breakpoint at the findAnswer method and then restart the application. Now this time, when the application stops at onCreate, I'll just hit the Resume button, which lets the application continue executing until the findAnswer breakpoint is hit. And I can now step forward in this method and examine the values of different variables to determine that 42 is indeed in the array, and that findAnswer sees it, but considers it the wrong answer. Anyway, as I'm sure you've figured out long ago, the problem is that I'm accidentally checking for not equals rather than for equals equals. So I'll fix that, and now I'll start over, and this time we'll see the correct behavior. And there it goes. And yes, the answer to life, the universe, and everything is indeed 42. Now, I think that debuggers help most when you have a reasonably good idea of where your problem is. and you can focus in on just a few lines of code. But in many other situations, that kind of low-level instruction by instruction examination that debuggers are so good at is a lot less helpful. Instead, it may be better to use more general tools that instrument your system and let you monitor its behavior over time. Android provides a number of these monitoring tools in its Dalvik Debug Monitor Service, or DDMS. Now today, I'll talk about just 4 of these tools: the File Explorer for viewing a device's file system, Logcat for logging and displaying runtime events, TraceView for displaying method execution traces, and the Hierarchy Viewer for examining user interface layouts. Let's look at these tools and see how you can access them from the IDE. First, let's start the device monitor, which exposes a number of panes and buttons for accessing the DDMS tools. Now here you can see a devices pane that shows the devices that are currently connected and shows a list of processes running on those devices. The first tool we'll look at is the File Explorer. This view shows you the files on the selected device's file system. For example, here we see that this device has a /data/data directory in which applications typically store persistent data. This device also has an external memory card mounted under /storage/SD card, and there are some standard directories there for storing music and movies and other things. The next tool I'll talk about shows the Logcat view. Android logs many events by default. And that is, as the software runs, it spits out information about the things that are happening on the device. And this information is stored and can be displayed in the Logcat view. Android also provides methods that let developers log their own information. Another tool is called TraceView. TraceView allows you to trace the methods your application calls. Let's do this for the answer application I showed you earlier. So this is the source code for the application. To simplify my demonstration, I'll first put a breakpoint in the onCreate method, and now I'll start debugging it. As you can see, it stopped at the breakpoint, and now I want to start profiling. So I'll open the DDMS tool window by typing Command 6 or Alt 6 in Windows. And then I'll click on the button that shows a clock and displays the text Start Method Tracing. Now I'll return to the debug view and resume the application. I'll let the program run for a while, and now I'll return back to the DDMS tool window and press that same button, but this time to stop the method profiling. And at this point, TraceView will process the trace information and show it to me graphically. The TraceView display has 2 panels. One is a timeline view showing the method call stack across time. The other is a textual view, which shows execution statistics such as the number of times the method was called, and the amount of time spent exclusively in that method, and the amount of time spent in that method, including any time spent in methods called from the current one. Additionally, you can search for a particular method by typing Command F or Control F. For instance, let's search for our old friend findAnswer. Now here I'll start to type in its name, and you can see that the methods are filtered until only findAnswer is left. And now I can zoom and pan on the timeline to see more information and surrounding context. The last tool I'll talk about is the UI Hierarchy Viewer. This tool allows you to examine your application's user interface and see how it's organized. For example, let's look again at the Hello Android application. First, let's run the Hello Android application. Once it's up and running, go to the menu bar and click on the Android Device Monitor window. And this will bring up the device monitor. And at this point, you can select the device on which the application is running, and then click on the Window, Open Perspective, and then Hierarchy View to open the Hierarchy Viewer. Go to the Windows panel and double-click the entry corresponding to the Hello Android application. And it's the one that has the words Hello Android in it. Now, double-clicking on this entry should bring up a graphical representation of Hello Android's user interface, which, like most user interfaces, is organized as a tree. For instance, there's an outermost application window, which holds the entire user interface. And it contains two children, a title or action bar, and then the large rectangular body where the application is seen. Each of these, in turn, contain further elements. So let's look at some of these other elements. When I click on the outermost window, I see what that entire window looks like. And I can inspect detailed information about it, such as its layout parameters, which shows, for example, how big the window is in pixels. The region occupied by each element is shown in the layout view in the bottom right corner. Now, for instance, I can see this information for the title bar, and I can see the same information for the body, and for the text view it contains.